Hi everyone, thanks for joining me. Good that you found this room at the very end of this building. My name is Ralf Sternberg. I'm working for Eclipse. I'm project lead of the rep team since many years, and I haven't been around at EclipseCon Europe for a couple of years, and I thought it's time to give you an update of what we are doing in the rep team. Like a sign of life, we are still there and we are still working on rep. And you may wonder what rep has to do with whiskey. It's a reminder of the few things in life that get better over time. And with 8 years of rep, I think rep is now a pretty mature framework. That's how I think about rep. It's really a framework that did not come up with so many new features every year. And it can basically do the same thing that it could do 8 years ago, but in a much better quality. And when we look back at the first version of rep, that was rep 1.0, it was released in October 2007. And I just for fun, I started up my rep 1.0 workspace, and you see it's still running. You see this workbench demo here, and you have a workbench and a web browser, and that was back in 2007, that was very exciting. Today it's probably not that exciting anymore. But that's what you can basically do with rep also now. Bring an RCP application into the browser with very little modifications. You see you can switch perspectives here, and you could even in rep 1.0, you could open an editor with dirty detection, and when you close it, you are asked if you really want to save your changes. All that was already there in 2007, and when you remember 2007, I don't know if you can remember the year 2007. Just to give you some context, 2007 was the year when Nokia announced this brand new exciting cell phone, the Nokia 6120 Classic. So there was no iPhone then. I had never seen a touch interface. I think even the word mobile as we use it now was not existing in this sense at this time. It was the time when everybody was going from rich clients to thin clients. Everybody wanted to go bring applications into the browser. But the browser market back then was like this. This is actually 2008, and you see this little green spot in the chart. That was Google Chrome. That was just released in its first version, 2008. So the browser market was still dominated by Internet Explorer, and that was mostly IE6, and horribly constrained web browser, which was extremely slow, maybe 7 or 8 times slower than other browsers at that time. And still IE8 was actually a browser where you could only set a single class, CSS class, to one HTML element. So it was really very complicated to build something sophisticated in the browser back then. But now we're in 2015, and the world has changed a lot, and we have all the browsers that are in use today follow certain standards, and that's why it was really time for us to do some cleanup. So we cleaned up old APIs, but the first thing of cleanup was we said goodbye to old browser versions. We discontinued the support, namely for Internet Explorer 8. And that was not an easy step for us, because a lot of customers still had Internet Explorer 8 around. But since I think the last operating system that shipped Internet Explorer 7 was Windows XP, which is not supported by Microsoft anymore. And so I think no responsible installation, productive installation, should use IE8 at this time. So these are the supported browsers in rep 3.0. And by removing support for IE8, we could throw out a lot of code that we needed to work around the shortcomings of IE8. IE9 is the first browser that implements a lot of the HTML5 standards, for example, the HTML5 canvas, so we could eventually use HTML canvas instead of this funny thing called VML. VML is, I think, proprietary vector graphics library. That was the only way to draw anything in old Internet Explorers. So now we can use HTML5 canvas in all browsers. We use CSS in all browsers, and that really helped us to throw out a lot of code, reduce startup time because the JavaScript library got smaller, and also to make our code easier. Because it was really, back in the old days, it was really like, we worked on rep and we worked on IE6 support. That was our old IE support that consumed 50% of our time. And we are very happy to say goodbye to that. Then we moved to Java 7. So on rep 2.x we moved to Java 5, and now we decided to move to Java 7. We don't easily move to new Java versions because not that we don't like to use new features of the class library, but we are very conservative in this regard because we do not want to force our users to new versions. We know that some of our users have pretty old environments, and they may have a problem with Java 7, and that's why we only made the switch to Java 7, not to Java 8. But it seems that in the near future we have to go to Java 8 because parts of the platform have recently moved to Java 8. I think the core jobs bundle is now on Java 8, and Jetty is on Java 8. So we're currently discussing what to do. Either we ship rep 3.1 still with Java 7, but with an older Eclipse runtime, or we keep in the simultaneous release and move to Java 8. Not sure what we do, and it basically depends on our customers. Maybe we can discuss this in the news group. Then we also cleaned up our API. We threw out everything that have already been deprecated in rep 2. So all the things that we threw out in Java 3 had been deprecated for more than 2 years. That's basically those I prefix interface names like iEntry point, iSession store. These have been renamed. iEntry point is now entry point, iSession store is now the UI session. And we threw out those classes and interfaces that represent internals of the platform. Everything that has to do with the thing called lifecycle, we think these are concepts that no rep developers should be familiar with. These are really internals. It's like a request comes in and it goes to certain states of processing, and these states have been called phases internally, and the whole request processing is called the life cycle internally. Not sure if that's a good word, that's for historic reasons. And all these things have been thrown out. They exist internally somewhere, but the API has been removed, and so you do not have to deal with these things. And one thing to mention is that all these APIs, maybe with one exception, which is the face listener, are only necessary if you develop custom widgets for rep. And for custom widgets, you can use this remote object API that exists since rep 2 as well. And now you really have to use it because the old APIs don't exist anymore. And with regard to face listener, there's just in the last milestone we added a new interface called UI thread listener, and that's a replacement for the face listener. So if you had some use case for a face listener, some code that you want to execute before and after every single request, so in other words, before the UI thread is entered and after the UI thread is left, then you can now use the UI thread listener. So that's for the cleanup. Now for features. What are the new features on rep 3.0? One of the most important things is reparenting. Reparenting is an API in SWT that allows you to exchange the parent of a widget. You know, there's a widget tree. At the very root of this widget tree, you have the display, and there are many multiple shells in the display, and widgets. Every widget has a parent, and and also a shell that it belongs to, and a shell is also a composite. So you can call, like on this red composite, you can now call set parent and move it to this other shell. And it looks like this line below. You call on a control set parent, that would be composite set parent shell. And the return value is a Boolean that tells you whether this action was successful or not. There were some SWT platforms that did not support reparenting, but I think the last platform that did so was Motive, which is not there anymore. So now all SWT platforms support reparenting, and REP also. So you will get a true result when you call set parent. And we did that actually because of E4 support. Because in E4, it's very common to move widget or entire views to a so-called limbo shell, an invisible shell somewhere in the background, and reuse those views later. Then we have graduated to widgets from the REP incubator, which is a side project of REP where we incubate new components for REP. The first of them is the Nebula grid. That's a grid widget from the Nebula project with the same API as this Nebula project, so you can also use this grid in SWT on the desktop and now in the web. And I think I started an examples demo here somewhere, so I can, where is it? Here. I think I have a Nebula grid here to show you if you don't know it. It's a very powerful widget. It supports, like a tree, you can have sub-items and expand and collapse them, and you can also have column groups which are expandable and collapsible. And this widget already existed in the incubator, and now it's part of the REP platform. And the second widget we graduated is the FileDialog. We did not support FileDialog because, of course, you cannot open files. You cannot save files from the browser directly to, let me put it this way, you cannot access the file system of the client from inside the browser. And that's why we could not implement FileDialog to open and to save files. But of course you can upload files, and with the FileDialog API, the FileDialog from SWT provides an API that you can use for uploading widgets. I have a little demo for that. Yeah, this one. So you can open a FileDialog, looks like this in single mode, and you can browse through your files and open some files and upload them. And if you open the FileDialog in multi-mode, then you can add multiple files and upload them. And you see the uploaded files, they are uploaded to some temp directory on the server, and these are the files that you get from FileDialog. So FileDialog returns you an array of files, and these are the files that you get. So it behaves just like on the desktop. And you can also drag and drop files from your desktop to the FileDialog. And there's one thing that is new in REP 3.1. You can also drop files. So you already in REP 2.3, you could drag files from your desktop to some control in your widget tree, like a file drop area. And now you can also open a FileDialog based on those files that have been dropped. Let me see if I can show you. I take this image and drop it to this file drop area, and then I open a FileDialog, and this file is already included in this FileDialog. So this is possible in REP 3.0. We have some improvements to the Canvas widget. Most of all, we now support clipping. So you can define a clipping region, and all the things that you draw are then filtered through this clipping region. In this case, my clipping region are those, consists of those rectangles there, which are now seen in purple, and then I draw a circle, and only the circle is only visible in this clipping region. And yeah, as I said before, the canvas is now completely based on HTML5 canvas, and in particular also texts are now drawn using the Canvas API. We could not do this before REP 3 because of restrictions that had to do with Internet Explorer, and we had to draw texts on top of the canvas, which resulted in an incorrect Z order. If you had some shapes that overlapped a text, that would not be drawn correctly. Now it is. So the canvas is much better now. And then we had some improvements to look and feel. We introduced a thing called badges, as you know them from mobile devices, for example. You can add badges to many widgets, and those badges will be positioned in a suitable location depending on the widget. And the badges are themable, so you can change the color and the font. And they also support texts, not only numbers, so you can also add letters or new or a star or whatever you like. And then if you look at this, at these three buttons here that are connected to a single button bar, this is a new feature that allows you to specify different borders on all four edges of a widget. That was often requested, but it was surprisingly complicated to implement because there is some API in SWT that returns the border width, and we also need to take the border width of a widget into account for the size computation. But this is now available in REP 3, and that allows you to connect widgets or to have a thicker border on the top as you have on the bottom, things like that. And then there's another thing that is new regarding scroll bars. The scroll bars are not always visible. Only if you hover over a widget they become visible. Maybe I can show you this feature. Oh yeah, here in the grid you can see it. Now you don't see a scroll bar in this left part, and when the mouse pointer comes into it, it's hard to see here because of the contrast. But you see that here, maybe you can see that there's a scroll bar at the side here that appears only when the mouse pointer enters a widget. This is completely themable, but it's enabled by default. Another thing that is new is unit test API. If you want to unit test your REP application code, and you want to test methods that create a widget or create the display or access a UI session, you had to create some test context that contained a REP context, including UI session, application context, and all these things. And we always had some internal API that was not public. There was always a big disclaimer on this class fixture that it's not part of the public API and use it at your own risk. And there were a lot of things that we only needed to test the internals of REP in this fixture, so it was a bit complicated to use. For example, if you wanted to test events in a custom widget, you had to include this line, fixture, fake, face, process, action, which was a bit like magic. You don't have to do this anymore now. We have a new unit test API that is called test context. That contains the entire context that you can set up. And it's a JUnit, you can use it as a JUnit rule. So with this annotation here, rule, this test context will be set up and torn down for every single test. So these lines is all that you need to write unit tests for custom widgets or web application code. And then you can start in your test methods to create the display, create shells, widgets, access UI session, and so on. And this test context can also be used to call methods on it, like, for example, replace connection. The connection is the interface in web that provides the remote object. So if you write a custom widget and you want to mock the remote object, then you can replace the connection with a mock connection, and this mock connection would then return your own remote objects. So one topic that concerns me since I'm a member of the REP team is performance. You know that in a REP application, all user sessions are kept on the server. All the clients access the server, and the widget trees of all user sessions are kept on the server. So if you have a lot of users, the server has obviously a lot to do. And how does that perform when you have hundreds, thousands of users? I was sometimes asked when I gave talks here about performance, and I never could come up with any real numbers. But interestingly, most of our customers was surprisingly had little concerns about performance. And now, eventually, one of our customers had some performance problems. They had a lot of user sessions, and they made a good analysis of some performance bottlenecks in REP, and also sponsored the work on performance that is part of REP 3.1. So we, with their help, we managed, the company is called MIG, thanks if there's anybody around them, from them. With their help, we managed to improve the performance between REP 2.3 and REP 3 significantly, as these two charts show. So this is REP 2.3. There are 1,000 user sessions on this that access the server. The user sessions are ramped up over an interval of 5 minutes, it seems. And then all these user sessions have maybe 100 requests, I don't exactly remember. And you see the response times are mostly below 250 milliseconds. So most of our response times, if you look at the colors, 25% is green. Most of the response times are probably much less than 50 milliseconds or so. But there are some responses that almost took a second. And in REP 3 it looks like this. So there are still some responses that took more than 500 milliseconds, but overall, if you look at the difference, there's a significant improvement. So we are very happy with this result. We executed these load tests using a tool called Gatling, and the performance tests are available in a GitHub repository called REP load test. So you can also check out this GitHub repository and run your own load tests, and also use this as a template for your load tests. So what did we do to achieve those performance improvements? Basically, one thing that this performance analysis brought up was that we create a lot of short-living objects in every request. The background is that in every request we have to capture the widget state when the request comes in and then compare with the widget state before we send the request to see what the difference is. And for this purpose we created a lot of objects that are only there for this single request. And well, creating an object does not take a lot of time, but if you create a lot of objects, then the garbage collector has a lot of work. And the garbage collector really turned out to be a bottleneck. So we try to avoid short-living objects by two measures. For one, we try to avoid using public APIs from internal code, which still do some checking and sometimes creating safe copies, because we don't need those safe copies internally. And the second is that we try to use less hash maps. We keep some state in hash maps, and when you fill in hash map, all the time you create hash entry objects, which are also objects, and I think not only one object, and hash entry is probably 3 or 4 objects, I don't remember. And now we save those, we save the state in dedicated objects, fields, so we do not create any objects, at least for the properties that are used very often. And one more smaller improvement is that now the first GET request, the GET request that gets the HTML file, is now a completely static request. Before REPS 3, this GET request always created a separate UI session. For no good reason. That was just because of historic reasons. And we continue those performance improvements in REPS 3.1, and one thing we do is to improve the change detection. And I want to talk about the details of this work for a moment. Maybe that's interesting for you. What we do on the REP server is we synchronize widget trees. Basically, every REP application has a widget tree. There's a display and the shells and many widgets, and the widgets are displayed in the browser, and they are also kept as Java objects on the server. So you have the widget tree in the browser and you have it on the server, and those two widget trees are synchronized all the times. The problem for performance is that you have many user sessions potentially, and you have many widgets. In common applications you have many hundred widgets, 300 widgets, 400 widgets. That's a common number. And you not only have many user sessions and many widgets, but all those widgets always also have a lot of widget properties. Like these are the public getters the public setters of the text widget. There's text, message, echo character, text limit, selection, editable, yes, no, and then on the right side there are a lot of properties that are derived from control, like visible, enabled, foreground, font, and all these things. And all these properties need to be captured and compared in every single request. So you have many user sessions multiplied by many widgets, multiplied by many widget properties. And all these, as I said, all these properties need to be preserved and compared before the request goes out. So this is the request processing. Basically, it works like this. A request comes in that tells the server that the user clicked on some checkbox, so the widget state has changed. The checkbox is now checked. And then we preserve the state. We go through all those widgets and preserve their properties in some kind of a store. Then we process the events. That means in case of the checkbox, there's a selection event which will be fired, and some listeners will maybe modify the widget tree. Oh, okay, I have to hurry up. and then the state is compared and rendered. And what we now changed is that for many of those properties, we do not record the state after applied changes, but we only record the state when the first change happens. And with this, we call this preserve on first change or preserve on demand, and this is part of REP 3.1. Now, since time is running out, I won't talk more about performance now. Maybe one hint, we always recommended using JMeter because we use JMeter internally, now discovered Gatling for load tests. Both are load testing tools that work fine with REP. Both support recording a session and then replay the session for multiple times. But Gatling also supports scripting, so you can you can script your sessions, and that allows for more configurable test scenarios. And what is more important for me is that with JMeter, I could never really interpret the graphs that I get. And with Gatling, I immediately see patterns. Like this is here you see a garbage collection problem. If you don't use the right garbage collector, you have those stop the world intervals. Okay, let me shortly talk about what we plan for REP 3.0. One thing that we have almost done is right-to-left support. So if you support Arabic languages or Hebrew languages, you have to mirror the entire UI. It's not, if you look at the Hebrew Wikipedia, for example, you can see what difference that makes. It's not only that the text goes from right to left, but also widgets are completely mirrored. For example, this grid widget, the collapse and expand icons are on the right side now. And if you see a combo box, then the drop-down button is on the left and all these things. So we had to touch every single widget. That was a lot of work. That was also sponsored by a customer. That will be part of REP 3.1, and we received another sponsoring for D3 charts. D3 is a JavaScript library that allows you to create very nice data-driven charts. If you go to d3js.org, you get an impression of what kind of charts are possible. There are charts that I had never seen before, and now we want to provide an extensible custom widget that allows you to bring those charts into REP applications. We plan to graduate the CK editor. That's also an incubator project at the moment, and we discovered that there is a Nebula rich text compatible widget. There's a Nebula rich text widget, and we plan to make our CK editor API compatible to this component. Not sure if we make it for REP 3.1, so that's an optional topic. And one thing that we would like to do is graduate the Eclipse E4 support. That's still in the incubator. Now with reparenting, things have become a lot better because you can now maximize and minimize views. And I had prepared a little demo, I think, or that will be my last demo now. Let me start it. Just to show you an E4 application in the web browser. So, yeah, you see, one thing that's interesting here is that in this view I can enter some text and then change perspectives, and you see the very same view instance is reused in this other perspective. And that's not possible without reparenting. And one thing that's also possible now is those fast views. Not sure if it's still called fast views. So you can minimize views, restore views, and this all works now. Okay. I would be happy if those of you who work on REP projects also contribute a bit to REP. You can not only contribute by writing code. It's also very helpful if you help out others on Stack Overflow, for example, or in the REP forum. If you report bugs that you come across, or that you add changes to our Garrett server. And also, as I told you, a lot of things in the REP project are really customer driven. We have at Eclipse Source this business model of sponsored development. So customers can sponsor a component that they need, and these components then become open source. And I think for us that allows us to work full time for several weeks on a project, and I think that's a very good model for like a win-win situation. It allows us to work more on REP, and for customers it's a way to get new functionality in the open source project at a guaranteed point of time. Okay, thanks for all of you who already contributed, and yeah, let's make a good black label REP in 1 or 2 years. Thank you very much. So, if we still have time for questions, I think we have until 5:30, so maybe 2 or 3 questions. Yes?
How hard is it to upgrade from 2 to 3? So we have the current REP 2 and using the E3 workbench, of course, because it's available. Is it hard to upgrade?
Not at all. As I said, we only threw out those APIs that had already been deprecated in REP 3, REP 2.3. So if you don't use deprecated API, you just change your target and that's it. Okay. Yes?
Other widgets from Nebula, you add porting of other widget Nebula?
Currently, we don't have any plans to support other Nebula widgets. But if you have any particular widget in mind, then let us know. Is there anything that you would like to see?
Nebula is a wide range of widgets, very interesting widgets. And so I just saw the grid and the one another, and so I was curious about
Actually, some Nebula widgets probably already work on REP because they use the canvas to draw themselves, and those widgets, like the P shelf, for example. I know that the P shelf works on REP because it uses Canvas API. Yes?
The new Nebula grid, is it possible that the customer can define own groups, or is it has a developer to define which grouping is enabled in Nebula grid, and the customer has not the chance to reorganize the grouping? I'm not an expert in Nebula grid, but so the API is like you have a column group, and as you create a column in a tree or table, you can also create a column group. So depending on who is the customer in your scenario, if that's a person who has access to the source code, then... but it's more fixed than the user within the web browser can... As example in Outlook, where I can group my mails.
Okay. So no, the widget itself does not have any UI for group or ungroup columns. Maybe one last question. Oh. Yeah?
What about the support of mobile browsers? So once upon a time you started a project for supporting mobile browsers?
We also support mobile clients. That's the Tabris project. They use the same protocol. But mobile browsers are mostly supported. I don't have them in this overview. We also support Opera and a lot of other browsers, but they are not tested so often.
Actually, for this, there will be a need for media selectors and for more support for the CSS stuff, which must be used to let the websites look well on mobile browsers. So there is no possibility to use these media selectors and to inject native CSS roots and so on.
No, I'm not sure about this. So basically, the mobile browsers, it comes down to Chrome and Safari, and those browsers are supported. So we do not test those browsers very often, but if there are any problems, then we rely on the community to report them. I'd say it works just like a normal web browser. Okay, I think I have to finish. Next speaker is probably already there. Yeah, thanks for coming. Bye.